Now, there's a relationship between equations in two variables and equations in one variable. In particular, if we have information about an equation in two variables, like its graph or a table of values, we can use those to solve closely related equations in one variable. In particular, we can use them to solve the equations in the form that we get when we plug in a value of y. Now, this isn't especially interesting when we're talking about linear relationships, because the equations we get when we plug in a value of y are linear equations that we can solve pretty easily. When we start to work with more complicated kinds of relationships, more complicated kinds of functions, more complicated kinds of equations, sometimes solving the equation algebraically, the way that we've been doing for linear equations, is difficult, or occasionally it's kind of impossible. We just need to have a computer do it or use trial and error. And so we're going to practice the technique now using a linear equation so that we know the technique when we get to these more complicated types of equations. So in this example, we are given the graph of y equals negative a half x plus 1. So maybe we had a computer make this graph for us, or maybe we made this graph using our existing techniques. And we're going to use this graph now to solve some related equations. The first related equation we're going to try to solve is negative a half x plus 1 equals 3. And notice that 3 is just replacing the y. We can get from y equals negative a half x plus 1 to 3 equals negative a half x plus 1 by plugging in 3 for y. And so we can solve this equation using the graph by finding a point on the graph where y equals 3. So we'll find the 3 on the y-axis and then follow this horizontal line across to the graph. This point has x-coordinate negative 4. This is negative 4, comma 3. And so we see that since the point negative 4, comma 3 is on the graph, this tells us that the solution to our equation in one variable is x equals negative 4. And we can check that that really works in our equation. We can check that it's really true that negative a half times negative 4 plus 1. Well, negative a half times negative 4 is 2. 2 plus 1 really does give us 3. We'll do the same thing for the equation negative a half x plus 1 equals negative 1. That negative 1 is taking the place of y. So we want to find the point where y is negative 1. Going back up to the graph, we find the negative 1 on the y-axis, scan across, and we find this point. This is the point 4, comma negative 1. And so since 4, comma negative 1 is on the graph, that tells us that the solution to our equation in one variable is x equals 4. And again, we can check that that really works by plugging in. So negative a half times 4 plus 1. Negative a half times 4 is negative 2. Negative 2 plus 1 is negative 1, which is what we hoped to see. So once we have the graph, we can solve the equations in one variable that we get by plugging in a value of y, just by looking at the graph. We can do the same thing with a table of values. So here we have a table of values for the equation y equals 5x minus 3. So each of these y values is what we get if we take 5 times the x value minus 3. So if we want to find a solution to the equation 5x minus 3 is 12, this is a value of y. We find a 12 in the y column. We see that the corresponding value of x is 3, and so the solution is x equals 3. We can check that that really works by saying 5 times 3 minus 3. Well, 5 times 3 is 15, so that'll be 15 minus 3, and that really does equal 12. Similarly, we can solve the equation 5x minus 3 is negative 13. This negative 13 now has been plugged in for y. We find a negative 13 in the y column. We see the corresponding value of x is negative 2. So x equals negative 2 is the solution to this equation. And again, we can check by plugging that in. 5 times negative 2 minus 3. Well, 5 times negative 2 is negative 10 minus 3. Negative 10 minus 3 is negative 13. So that really did work. If we're in possession of a graph or a table of values, then we can use those to solve the kind of equations that we get when we plug in a value for y. This isn't terribly powerful for linear equations, but for more complicated types of equations, this is going to be very valuable.